The moment the electrical grid fails, the average modern home begins a rapid descent into an unlivable state. During the energy crises of the 1970s, Americans discovered their absolute dependency on external supply lines. We built a society that requires a continuous, uninterrupted flow of commercial power just to maintain basic survival. Yet just a few counties over, an Amish farmhouse sits in the dead of winter, perfectly warm, without drawing a single watt of electricity or utilizing a single moving part. This structure functions as a thermodynamic organism. It utilizes ancient physics to maintain an internal equilibrium, regardless of the temperature outside. At the center of this organism sits a 3,000-pound masonry heater. It requires exactly 1 rapid fire per day to maintain its output. A conventional fireplace is a thermodynamic failure. It routinely exhausts 600-degree heat straight up the chimney, losing the vast majority of its energy to the winter sky. The Amish solution involves sealing the firebox and driving temperatures to 1,800 degrees to burn the volatile smoke itself. This exhaust is then forced through a labyrinth of internal channels, known as a contraflow baffle. As the gas snakes through this masonry trap, it surrenders its heat to the dense fire brick. This creates thermal mass. The brick acts as a massive thermal battery, absorbing nearly 900 joules of energy per kilogram, radiating warmth for 18 hours. Survival in extreme cold relies on a shift in strategy. Instead of burning fuel to heat leaking air, you charge the solid mass of the structure itself. In the large, uninsulated barns, we find the secondary system, the structure's energy reserves. This relies on the specific heat capacity of water, which stores approximately 62 British thermal units of energy for every gallon for every degree of temperature rise. Farmers position 55-gallon steel drums filled with water along the interior north walls, opposite south-facing windows. Painted flat black, the drums absorb 95% of the low-angle winter sun's radiation. They store thermal energy all day, and as the ambient temperature drops at night, the mass radiates that heat back into the barn. This passive heating loop requires no intervention, adjusting its output naturally based on the Earth's orbital tilt and the seasonal angle of the sun. During a 95-degree summer heatwave, a commercial dairy farm can spend $800 a month in electricity just to prevent heat stress in its animals. The Amish bypass this cost with an earth-air heat exchanger, which functions as the deep respiratory system of the barn. This system uses a trench 6 feet deep, containing 100 feet of hollow clay pipe. As hot exterior air is drawn into the opening, the stable, cool earth surrounding the clay physically strips the heat out of the incoming airstream. At the midpoint, an unglazed clay jar called a Wasserkrug weeps moisture into the air. This triggers evaporative cooling, dropping the temperature of the passing air an additional 10 degrees. Warm air rising toward roof vents inside the barn creates a pressure differential. This naturally draws the refrigerated 48-degree air out of the ground without the need for a motorized fan. For a $300 investment, this system operates for a century with no moving parts, leveraging the deep cold of the earth rather than a mechanical compressor. If these passive systems operate with near-perfect efficiency and zero ongoing cost, we must investigate why modern construction abandoned them. By the 1950s, the market shifted toward active electrical solutions. Comfort was redefined as an appliance you purchase, rather than a physical property of the building. The $200 billion HVAC industry relies on systems that eventually fail. A house regulating itself through physical materials is a flawed business model for a modern corporation. These methods represent an unbroken chain of engineering. From the Roman hypocaust to the Korean ondol, ancient builders treated structures as partners with the natural forces around them. Survival sovereignty comes from the physical mastery of thermal mass. By integrating these systems, a home becomes an independent, living organism